Engineering Exploration. I am Maithili Sharma from Team 3J Division. We are designing a multi-purpose Agri bot. Problem definition. Design a semi-automatic Agri bot controlled by an Android mobile which plows the soil, sows the seeds and waters it. It should be portable, user-friendly and should not exceed the volume of 2700 cc. The machine should sow at least 10 seeds per minute and the budget must not exceed 500 rupees and it should work for 3 hours continuously. The following is the function tree and the functional clustering. Subsystems identified: plowing, seed sowing, water dispensing and movement. 4 concepts were generated and the first concept is as follows. The seed would be sowed through gravity drop method and the water would be also dispensed using gravity drop method. There were wheels attached, thus it could move on the soil bed. In the next concept, plowing blades were attached so as to make it easy for seed sowing, and the seed would be sowed using gravity drop method and water would be dispensed using water sprinklers. In the third concept, the water would be dispensed using gravity drop method, but the seed would be sowed in multiple rows using a cylinder which would rotate. This concept has wheels attached to it, thus it can move on the soil bed. The fourth concept, wherein the bot would be attached to the soil bed, the seed would be dispensed in multiple rows using the cylindrical dispenser and the soil will be plowed using plowing blades. But here the bed will be movable and the bed will move. The finally selected concept is the fourth concept. Here the seed dispenser will move using servo motors. Also the plowing blades will be controlled using servo motors, and as soon as the sensors do not detect an object in front of it, the soil bed starts to move. This concept was selected as it was the optimized concept.
Virtual implementation. 3D model of the. This is the 3D model of our AgriBot. This is a conveyor belt. This is a water container, and here we have plowing blades attached to a servo motor and a seed dispenser attached to a stepper motor. And this is the frame. And here are the holes present on the seed dispenser along a single line axis. As the seed dispenser rotates, when the holes reach the bottommost part, due to the gravity, seeds are dispensed over soil bed. And this is a conducting tube which conducts water from the water container to the soil bed. Circuit diagram of our entire system. These are two DC motors which are used for functioning of the conveyor belt. This is a stepper motor which is used for seed dispenser. And here are two sensors which senses the soil bed entering and leaving the frame. And here is the Arduino kit which controls the function of our system. And here is the power supply.
Flowchart. Start. Fire sensor senses the soil bed. Condition is true. Conveyor belt moves. Condition is false. Conveyor belt does not start. Seed dispensing starts rotating. Plowing blades align to reach the bed. The soil bed moves. Water dispensing gets activated, and water and seed dispenses simultaneously. The bed moves out of the frame. Condition true. The conveyor belt stops. New condition is false. New soil bed is inserted. The process will stop here. Bill of material. Material to be purchased are Arduino Mega 2560 quantity 1. The cost of each material is 650. 2 channel relay quantity 1. Cost of each material is 156 rupees. DC motor quantity 2. Cost of each material is 145 rupees. IR sensors quantity 2. Cost of each material is 45 rupees. Jumper wires quantity 30, cost of each material is 6 rupees. Breadboard, quantity 1, cost of each material is 95 rupees. Screwdriver, quantity 1, cost of each material is 29 rupees. Servometer, quantity 1, cost of each material is 149 rupees. Battery, quantity 1, cost of each material is 200 rupees. Frame large, quantity 1, cost of each material is 350 rupees. Frame small, quantity 1, cost of each material is 250 rupees. Fasteners, quantity 12, cost of each material is 150 rupees. Cylindrical dispenser, quantity 1, cost of each material is 200 rupees. Flowing plates, quantity 1, cost of each material is 150 rupees. Plastic container, quantity 1, cost of each material is 40 rupees. Plastic tubes, quantity 2, cost of each material is 20 rupees. Conveyor belt, quantity 1, cost of each material is 500 rupees. Soil bed, quantity 1, cost of each material is 200. Tray, quantity 1, cost of each material is 50 rupees. The total cost of materials is 4019 rupees.
Motor sizing and battery sizing of the entire system. By doing suitable calculation, we get the torque load required as 0.55 kg/cm. From the table DC generated motor specification, we get the appropriate rate of DC motor, that is 150 rpm motor. Battery sizing. From suitable calculation, we get the required battery as 24 volts. Function specification of the entire system. The first function, to detect the presence of the soil bed on the conveyor belt. The sensor will sense and sends the digital info. The second function is conveyor belt movement. Receiving the information from the sensor, conveyor belt starts to move. Third, alignment of the ploughing blade. With a specific time delay after the conveyor belt starts, ploughing blade align perpendicular to the soil bed using servo motor. The fourth function, seed dispensing. Using stepper motor, seeds are dispensed through the holes present along a linear line present on the cylindrical container containing seeds. The last function, water dispensing. Water is dispensed through the tiny pores present on the tubes, which follows the simple method of drip irrigation. We have done a modeling and simulation of Agri board on Tinkercad. This is a circuit implementation of our Agri board on Tinkercad. The code is fed over here to obtain the required result. Once we start simulation, the conveyor belt starts moving as it senses the soil bed kept on the conveyor belt. The ploughing blade aligned themselves, and the next seed dispenser starts rotating. And once the soil bed reaches out of the frame, the ploughing blade once again align themselves perpendicular to the soil bed and seed dispenser stops rotating. Thank you for patiently hearing our report.